All right, now we are going to do the hard work of actually balancing. Are you ready? Okay, so here we're going to start with checking to see if it's balanced. So I like to think about this PO4. I know that's a polyatomic ion. Do I see it as PO4 on this side? Well, yes, I absolutely do. So in my list of elements, I'm actually going to write the polyatomic ion. Okay, so I have one on this side and I have one on this side. I do have another polyatomic ion, which is OH. And it's on both sides, just like that. So I have one OH on, oops, that's a little messy. So I have one OH on the reactant side, and I have one OH on the product side. Now I just look at what's left. So I have Na, and I have 3 of them, and I have K, and I have 1. So on this side, for Na, I have 1, and for K, I have 3. Okay, well, that is definitely not balanced, right? So let's just fix Na first. Well, I have 3 on this side and 1 on this side. Here's the thing. We can only fix it by multiplying, okay? Like I can't divide this by 1 and make it smaller, okay? All I can do is multiply. So I'm going to want to multiply this sodium times 3. That would balance it, right? So what do I do with this 3 that I multiplied by? I'm not looking at the answer. I'm looking at what I multiplied it by. I bring it up here and I put it in front of the Na compound as a coefficient. But as soon as I do that, it changes this OH. So now that OH is times 3. Well, I fixed the Na and messed up the OH. Okay, great. So let's try and fix the OH now. All right, so remember I can only fix it by multiplying. So let's go on this side and multiply this OH times 3. When I do that, I put the 3, the coefficient I multiplied by, in front of the compound that has the OH. And when I do that, it didn't only change the OH, it changed this K. So I multiply the K times 3. And hey, you know what? Actually, that fixed the K. So when I look at these, PO4, 1 and 1. OH, 3 and 3. Na, 3 and 3. K, 3 and 3. It's balanced. I check to make sure I can't reduce it. Well, what do I do with the blanks? Well, on the blanks, if a blank stresses you out, you can put a 1. But it is acceptable to just leave it blank. Never, ever, 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 ever write a 0. That means you just erased it. It's not there. And that definitely messes it up. So how do I determine smallest whole number coefficients? I check. Can I divide all of the coefficients? My ratio of my coefficients is 1 to 3 to 3 to 1. Can I divide all of those coefficients by something other than 1? No, I cannot. It's balanced. All right, let's try the next one. This one's a little easier because we only have P and O. P and O. So I have 4 and 2 and 2 and 3. Okay, well, neither are balanced, so I can technically start wherever I want. Where do I like to start? Well, I like to start on the side where it's as a compound. So do you see how these 2 are elements on this side? I'm not going to start there. I'm going to start on the compound side. And it doesn't really matter which element I pick, except, do you see how oxygen is even? It's a 2 and a 3 and odd on this side. I like to start with the one that is odd and multiply it by 2. Why? because now it's even. That's one way to make it even, right? What number do I put as the coefficient? Remember, it's what I multiply by. So that 2 goes right here. When I put that coefficient of 2, it didn't only change the O, it changed the P. So times 2 is 4. Okay, so it fixed P, beautiful, but O is still not right. How do I fix it? I need to get a total of 6. So I multiply this by 3 to get 6. I put the 3, the coefficient I multiplied by, in front of the O. Does that change anything else? No, it does not. What can I put in the blank? A 1. So let's look at my ratio of my coefficients. It's 1 to 3 to 2. Can I multiply them all by, divide them all by something other than 1? No, I cannot. So we're good. And if you double check, you have 4 P's, 4 P's, 6 O's, 6 O's. Works. All right, so let's try this one. And I don't obviously write this every time. I can do it in my head now. But it's better for you to continue to write it. Okay, so let's do it. C, F, B, R. I didn't leave enough space last time. It was a little crowded. So let's do it this way. So C's we have 1, F's we have 4, BR's we have 2. Go to the product side. C we have 1, F we have 2, BR we have 4. Okay, well, remember what I said? We want to start, if we can, with something that's in a compound. So like BR and F, I guess then it doesn't matter, right? Because on each of them is in a compound on one side. So I'll just start with this one. F has 4 on the reactant side and 2. So remember, I can only multiply to fix it. So I multiply it by 2. The 2 I multiplied by is the coefficient that goes up there in front of the F. Well, maybe that wasn't the best way, but that's okay. We'll just keep going and let's see if we can fix this. BR. Okay, so that didn't mess up anything else because there was nothing in this compound, right? So BR, how do I fix it? Multiply this one times 2 to get 4. The 2 goes as a coefficient in front of BR. And, well, that's not with anything else. Huh, look at that. 1C, 1C, 4 F's, 4 F's, 4 BR's, 4 BR's. What do I put in the blanks? 1's. Check my ratio of coefficients. 1 to 2 to 1 to 2. Can I divide these numbers by anything other than 1? No, I cannot. So I'm all set. All right, let's check this one. So I have GA, F, and CS. GA, F, CS. Let's count what we have. 1 GA, 3 F's, 1 CS. 1 GA, 1 F, 1 CS. Okay, well, the only thing that's messed up right now is F. So let's fix it. Multiply this by 3. The 3 that I multiplied by, the coefficient, goes in front of wherever F is on that line. But when I put it there, it also changes CS. So before I forget, multiply the CS times 3. So yes, I did fix F, but I messed up CS in the process. So let's fix CS times 3. The 3 I multiplied by becomes the coefficient in front of CS. And will you look at that? It's fixed and it doesn't have anything else with it. So I have 1 GA, 1 GA, 3 F's, 3 F's, 3 CS's, 3 CS's. What do I put in the blanks? 1's. And then I check the ratio. 1 to 3 to 3 to 1. And no, I cannot multiply, I cannot divide those by anything other than 1. All right, so let's continue right here. All right, so this one I'm going to try to show you how I do it shorthand without writing everything out, okay? So I'm going to look, NA looks fine, F is not fine, and BR is not fine. So let's just start with F. This side has 2 F's, this side only has 1. So multiply this by 2. That fixes F, but now NA, I need 2. And then look, watch this. 2 times 1 is 2 NAs. 2 times 1 is 2 NAs. 2 times 1 is 2 F's. 2 F's. 2 BRs. And 2 times 1 is 2 BRs. So it is balanced. So this is 2 to 1 to 2 to 1. So fun fact, if any of the coefficients is a 1, then I literally can't reduce it. So I know it's right. Okay. All right, let's look at this one. Well, this one looks more complicated, right? All right, let's see what's going on. So I'm going to write this one just because I want to show you something. I have PB, O, H, and CL. PB, O, H, and CL. I obviously have to have the same elements on each side, otherwise wouldn't show conservation of atoms. So on the product side, I have 1 PB, 1 O, 2 H's, and 2 CL's. On the reactant side, I have 1 CL, 1 PB. O is in here 1 times 2, so I have 2 O's. And then H's, I have 2 H's right here, but then I also have an H over here. So I have 2 and 1. So together I have 3 H's. This is where it gets a little complicated. So, well, I don't want to start with PB because that's balanced, right? O is not balanced. H is not balanced. CL is not balanced. But O is in this complicated formula right here. So that's where I'm going to start. And also, tip. If you're like, I don't even know where to start, and you want to cry and scream, put a 2 in front of the most complicated thing and see what happens. Let's try it. So when I put this 2 here, the PB gets multiplied by 2, right? The O gets multiplied by 2. And this H gets multiplied by 2. So 2 times 2 is 4, right? Plus this 1. So now I have 5 total H's. Okay. Let's just keep going and see if we can make it work. Okay. On this side, all right, what do I do? Well, I have 2 PBs over here. So let's try and make this have 2 PBs on this side. So that 2 becomes the coefficient in front of PB. When I do that, okay, oops, I just noticed I did 2 times 2. That should be, let me actually erase it for real. 2 times 2 is 4. Oops. Okay. Anyway, let's go back here. So PB I have 2, but also I had to multiply the CL times 2 to get 4. I'm still going back over here. I checked the PB, I checked the O, and I checked the H. Okay. And then, so I fixed the PB. Well, let's try and fix the O. Okay. So in order to fix the O, I have to multiply it times what? 4. That's when I noticed I did the math badly. I apologize for that. So times 4. And that's okay. That's actually a perfect example of when you make a mistake, just go back and fix it. So this 4 becomes the coefficient here, right? But when I do that, it also changes the h. So this is times 4, which gives me 8. And if this h is like a mess, so if I could leave that to the end, that would be beautiful. I would love it. So let's try and fix CL. So when I do that, I multiply it times 4. This becomes the coefficient in front of the CL. And when I do that, right, well, it is this h. So this h is times 4. So I have 2 times 2, which is 4, and 1 times 4, which is 4, which is 8. Okay, so everything balances, right? So now let's look. I have 2 to 4 to 4 to 2. Can I divide those coefficients by something other than 1? You betcha I can. I can divide them all by 2. So my ratio should be 1 to 2 to 2 to 1. So I fix these coefficients. It should be 1, 2, 2, and 1. This is sometimes what you have to do. And it's practice, it's trial and error. That's a big part of balancing. And you just have to go for it. Okay? All right, let's continue. Here we go. So let's see. I have AL on this side. I have 2. On this side, I have 1. BR, I have 3 and 1. Okay, this SO4, I feel like this is where I want to start. Okay, first, this is the most complicated looking formula. And I have 3 SO4s over here. But on this side, I only have 1. So I'm going to make this be 3 SO4s on this side. But when I did that, I made 3 times 2, 6 Ks. So let's make 6 Ks on this side. Good. But this made 6 BRs. If I put a 2 here, now I have 6 BRs. So this is good. I have 3 SO4s, 3 SO4s, 6 BRs, 6 BRs, 6 Ks, 6 Ks. Now what about AL? This is 2 ALs. Oh, look, 2 ALs. Beautiful. So that's kind of how I do it without writing out the list, okay? So what coefficient goes here? 1. What is my ratio of coefficients? 2 to 3 to 6 to 1. No, I cannot divide by anything other than 1, so I'm finished. Okay. All right, so let's look at this one. I have 1C, 1C. That's good. 4 H's, 2 H's. Now I have 4. So 4 H's, 4 H's. 1C, 1C. O's is complicated because look, over on this side, I have 2 O's. And right here, I have 2 O's. So that gives me 4 O's altogether. On this side, I have 2. So if I put a 2 here, now I have 4. And that's it. I'm balanced. I could put a 1 here and a 1 here, my ratio. And since my ratio of coefficients includes a 1, I know I'm finished. All right. Let's look at the next one. Well, I have 1K and 1K on each side, but CL, I have 2 CLs here and 1 here. So put a 2 here. So that has 2 CL and 2 CL. But now I have 2K, so put a 2 here to make that be 2K, and then I'm done. So that's a 1. So the ratio of my coefficients is 2 to 1 to 2. And that's it. All right. Now let's see. Let's look at this one. I have AL 1, H 2, So this is, I already know it. It's a trial and error by one, so I know what I would do to start this. But I'm going to show you what might happen as you try to balance this one. So you might say, okay, I'm going to look here. I have CLs. I have 3 CLs here. I'm going to put a 3 here. When I do, I now have 3 H's. And now look over here. Here's the problem. I have 2 H's here already. I can't, there's no number I can multiply 2 by to get to 3. So I know this is wrong. Okay. So, and if I put a 2 instead, right, based on the hydrogens, it doesn't work either with the chlorine. So where do I start? Remember when I said sometimes just put a 2 in front of the most complicated looking thing and see if it all works out. So let's put a 2 here. See what happens. So that makes 2 ALs. 2 ALs. 2 times 3 is 6 CLs. Okay, I could put a 6 here and make 6 CLs. Can I make, this is 6 H's, right? Can I make 6 H's? Absolutely I can by putting a 3. It is balanced. So 2 to 6 to 3 to 2. Well, no, I can't divide by anything other than 1. So voila, finished. All right, let's check this one. I have 2 N's, 1 N, 2 F's, 3 F's. Well, I don't know, you got to start somewhere. So let's try and fix the N's. Put a 2. So I have 2 N's and 2 N's. 2 times 3 is 6 F's. Can I make this be 6? I sure can by putting a 3 in front of here because 3 times 2 is 6. So this just needs a 1. So my ratio is 1 to 3 to 2. And nope, can't divide by anything other than 1. All right, this next one, this one right here, ooh, hot mess, right? So I'm just going to follow my own suggestion and put a 2 here and see if I can make it work, okay? So let's try. All right, so I have to figure out what this did. So for nitrogen, I have 1 nitrogen inside times the subscript of 2 is 2 times the 2 in front. So I have 4 nitrogens. Okay, make this have 4 nitrogens. There we go. All right, for H's, I have 4 inside times this coefficient, this subscript. So 4 times 2 is 8 times the coefficient. So I have 16 total H's. Over here, I have 4 times 3, I have 12. That's not enough, right? So what's 16 minus 12? Well, that's 4. So I need 4 more hydrogens. But look, I have a hydrogen right here. And I have 2 of them. So if I put a 2 here, that would be 2 times 2, which is 4. So that does give me my total of 16. Perfect. All right, what about S? I have 1 times 2, I have 2 S's. 1 times 2, I have 2 S's. 4 times 2, I have 8 O's. 4 times 2, I have 8 O's. So I have coefficients of 4, 2, and 2. So can I divide the numbers in this ratio by anything? You betcha. I can divide them all by 2. So this is going to be 2 to 1 to 1. So although the numbers balance, the correct answer is this because I need the smallest whole number coefficients always. Okay? So there's some balancing practice.